All right, here we are in section 4-3, numbers 13 through 15. We're graphing the solution to the systems of inequalities. So we're going to be graphing each inequality separately and then coloring where they overlap and then labeling the vertices. So solving the system of equations with equal signs in them. All right, so number 13, we'll take this color for number 13. Y is greater than or equal to 2/3 x minus 4. Treat it like an equal sign, and we get y equals mx plus b. We're here down here at -0, -4, and then up 2 over 3 looks about like that. And then this says it is a solid line, so it looks about like that. Good. And it says y is greater than, so this entire upper side of the line would be colored. We'll color the rest when we see what the other guy does. So take this color for this one, y equals -2x plus 12. So we're way up here at plus 12, and then we go down to over 1. So it looks about like that, and there we go. Okay, so now y is greater than. So again, we're on the upper side like this. All right, so that means let's take a color here that's kind of innocuous, and oh, there we go. That is the solution. It's between those two lines there. So now we're interested in finding the vertex, the point right down there in the center. So we notice that we are set up very well for substitution. If you write out the equation y equals 2/3 x minus 4, and the other equation y equals -2x plus 12, we're set up for substitution because y is by itself, so we can write -2x plus 12 equals 2/3 x minus 4. And we have an equation. We can now solve this. Let's get rid of that fraction right away. Times everything by 3 to get rid of the fraction. There we go. And we are left with -6x plus 36 equals 2x minus 12. Add 6x over to here, we get 8x. Add the 12 over to here, and we get 48. Divide by 8, and we get x equals 6. Okay, so that's half of it. We now know that this is 6 something. So we plug it back in to any of these. So y equals -2x plus 12, and we get y equals -2 times 6 plus 12. So we just took that 6 and put it up there for the x, and we get y equals -12 plus 12 is 0. Oh, looks like our graph was just a hair off on this one. Should have come down about like that. 6, 0. So that's the vertex. So our graph is just a little bit off. If we were a little bit more accurate, we would have been right on the line. All right, number 14. Let's take this color for this guy. 5x minus 7y is less than or equal to 1. Subtract 5x from both sides. We get -7y is less than or equal to -5x plus 1. Divide by a -7, divide by a -7, divide by -7, and that flips this direction. So we are at y greater than or equal to 5/7 x minus 1/7. So we're right here, right below the origin, and then we go up 5 over 7 like that, and it is a solid line. Good. So there we go. And it says y is greater than. So we are up like this right now. Now let's get our second color out. And it says x is smaller than 3. X is larger than 3. So we go over to where x is 3, and it's a vertical line. It says it's a dashed line. There we go, like that. And it says x is bigger than 3. We don't have a y to verify we go up or down, but this x is left and right, and so it's x is bigger than 3. We go to the right of 3. So we're like that. And so if we look at the crossing of those two regions, it looks like it's this area right in here. There we go. So now we're interested in that point right there. Let's see if we can get that. Let's write out the two equations as equal signs. 5x minus 7y equals 1. And the other one is x equals 3. Well, look at that. We already have one answer. 3 what? Stick 3 into there and we get 15 minus 7y equals 1. Subtract 15 and we get negative 7y equals negative 14. Divide by negative 7, we get y equals a positive 2. So that is the point 3, 2, and that's the vertex. Alrighty, let's move on to number 15. We have 4x plus 5y is less than or equal to 7. So let's subtract 4x from both sides and we get 5y is less than or equal to negative 4x plus 7, and then divide by 5. Y is less than or equal to negative 4/5 x plus 7/5. Now notice on this one we don't switch the direction because we did not divide by a negative 5. All right, so we go up to positive 7/5 is about right there, and we go down 4 over 5 like that, and so we are solid. It's a solid line there. There we go. Okay, now change the color, and here it's already solved. Y equals mx plus b, so we're going to be y is, oh, we forgot to do what side, dang it. Y is smaller than, so that means we're going down this way. Okay, now the other color. So y is bigger than negative 4/5 x minus 6. So 0, negative 6 is about right here, and we go down 4 over 5 like that. And this is a dashed line. And it says y is bigger than. So this is headed up here this way. Ooh, that means the area is in between these two lines. And the question is, do they ever cross somewhere? Well, if you look at this slope and you look at that slope, they don't cross. They're parallel. This is inconsistent without us even trying, but let's try anyway just so we can see that happens. But yeah, you could stop right now and say, oh, negative 4/5 slope, negative 4/5 slope. They had different intercepts. That means this area goes on forever and ever, and there are no vertices. There's no intersection of these two lines. But if we were to write it out, 4x plus 5y equals 7, and y equals negative 4/5 x minus 6. It's set up for substitution, so we take that guy right there. 4x plus 5 times negative 4/5 x minus 6 equals 7. Jump the 5 in, and we get 4x. That goes into there, and we get minus 4x. Minus 30 equals 7. 4x minus 4x. Negative 30 equals 7. This is absurd. There is no solution. There we have it. Alrighty.